Okay, this is question 1b. Use the substitution u equals root x minus 1 to integrate this. So I'll move it across a bit to give myself some space. So first of all, we're starting with u is root x minus 1. So u equals root x minus 1. Just be careful when you rewrite it that you don't put the square root over the minus 1 as well. Otherwise it will be a completely different function. Right, and we're trying to integrate, move this across, 1 over root x minus 1. Now because x is the variable here, you're integrating with respect to x, so I'm going to keep it like that. Now, a couple of things to notice. It says we've got to use u, at the moment we're integrating with respect to x, so we have to replace the dx with something. To do that, I'm going to differentiate this. So du dx is, now x rooted is x power of a half, therefore differentiated is a half x to the power of minus a half, and the 1 disappears. So now we're here, we want to rearrange to get dx equals, so I'm going to rewrite the right hand side. Du dx equals a half, so I'm going to keep it as 1 over 2. Now x to the half is root x, the negative is the reciprocal, so it's 2 root x. Just looks a bit tidier to move around. Then I'm going to move the 2 root x to this side and bring the dx up. So I'm going to get 2 root x du equals dx. Okay, so now I've got that written, I can replace the dx in this part here. Let me highlight it. I can replace the dx for this. Okay, I can also replace the root x minus 1 for u, and let's see where we end up. So integral, sorry that's too big, keep it red. So it's the integral 1 over, now becomes 1 over u, dx, well dx was 2 root x du. So I've replaced it all. Now I need to see what I've got. In here I've got my x. Now the problem with that is I'm integrating with respect to u, so I can't do that. So what I'm going to do is I'm going to look at this a bit over here and say, well, if I know that u is the same as that, if I add 1 to this side, that tells me, and I write it down here, that u plus 1 is root x. And now I can write my root x as u plus 1. So I can now replace u plus 1 for my root x. So we end up with the root of 1 over u times 2 times u plus 1 du. Okay, now we've got rid of all the x's, we need to simplify it. So I'm going to do the 1 over u times 2. I always take the, you don't have to, but I'm going to take the coefficient out of the integral. So it's 2, and that leaves me with u plus 1 over u du. I'm going to separate these out, so it's the integral of, so u over u is 1, and 1 over u, I'm just going to leave as 1 over u, du. Right, now moving on from there, we can do the integration, so it's 2, the integral of 1 is just u, and the integral of 1 over u is ln u. And that's it, that's the integration done. There are no limits, however, so we're going to have to keep the 2, and we're going to replace the u for the original function, and we're going to have to plus c as well. So I'm going to go write this as 2u plus 2 ln u plus c. But then when we replace the u in, so this becomes 2 lots of, the original u was root x minus 1, so 2 lots of root x minus 1 plus 2 lots of ln u. Now because when you put a function after ln, it doesn't exist if it's negative. So you have to decide whether your bracket can be negative or not. So I'm going to put curved brackets for now, root x minus 1 plus c. But if we consider what's in here, there are situations when this could be negative. So this could be negative, could be negative. So therefore you have to have absolute values around that. So your final answer is 2 root x minus 1 plus 2 ln modulus root x minus 1, and I'll just squeeze on a plus c at the end. Okay.